There is a rule in horror storytelling that never really loses its power, no matter how many times it's used. And that rule is simple. The monster is already inside the house. In the insect world, that rule applies more often than most of us realize, because sometimes the danger, or at least the strangeness, is not lurking outside the body at all, but already within. Today, on this episode of Insects for Fun, we are talking about an order of insects and other arthropods that live inside insects, not briefly and not by accident, but as a regular and sometimes lifelong way of existing. Before we go any further, I have to state that the animals we are talking about today are not parasitoids. Parasitoids are defined by the fact that they must eventually kill their host in order to complete their development, and they usually do so with ruthless biological efficiency. I've already mentioned them before on multiple episodes of this show, and there's still so much more to cover on them, but that's for another time. In other words, if parasitoids are full-blown body horror films, then the organisms we're talking about today are more like psychological thrillers that unfold slowly and quietly under the surface. So let's just jump right into the only insects that made it on this episode, Strepsiptera. Among the strangest insects to ever evolve are the twisted wing insects, known scientifically as Strepsiptera. This is an entire order of insects that has taken the idea of living inside another animal and pushed it to an extreme that borders on the unbelievable. Strepsipterans spend almost their entire lives inside other insects, including bees, wasps, leafhoppers, and plant hoppers. And they do so in a way that blurs the line between parasite, symbiont, and permanent biological resident. If you're wondering where the name twisted wing comes from, it's actually a very literal translation of the order name Strepsiptera, derived from Greek roots meaning twisted and wing. This name refers specifically to the adult males whose hind wings appear twisted when folded and are used for short, frantic flights. Females look so different from the males that for a long time early entomologists didn't realize they belonged to the same group. Male strepsipterans are small, free-flying insects that exist for one purpose only, which is to find a mate. Their adult lives are incredibly short, often lasting only a few hours, and they don't feed at all during this time. Many species lack functional mouth parts entirely, meaning that once a male emerges, his biological clock is already ticking. Because of this fleeting existence and their erratic flight patterns, they are very, very rarely seen, even by entomologists who know exactly when and where to look. Females, on the other hand, never leave their host at any point in their life. After the larval stage enters a host insect, the female remains permanently embedded within the host's body, retaining a larval-like form. Only the front portion of her body protrudes from the host's abdomen, forming a small opening that allows males to locate her for mating. From that point on, her entire life unfolds inside another insect. Mating itself is one of the most unusual processes in the insect world. The male does not enter the host's body. Instead, he inseminates the female through the exposed opening, after which the female produces thousands of live young rather than laying eggs. These microscopic larvae burst from her body, crawl onto the host's exterior, and disperse into the environment to find new hosts, beginning the cycle again. What makes this relationship especially fascinating and especially relevant to this episode is that the host insect often does not die as a direct result of the infection. Instead, the host becomes stylopized, a condition named after the genus Stylops, one of the best-known strepsipterans. Stylopized insects experience suppressed reproductive development, altered hormone levels, and subtle behavior changes. In many cases, infected hosts stop attempting to mate altogether. Even more surprisingly, some stylopized insects appear to live longer than uninfected individuals. By shutting down reproduction, the strepsipteran may actually reduce the physiological strain on the host, effectively converting it into a longer-lived vehicle that continues feeding and moving through the environment. For the Strepsipteran, a living host is vastly more valuable than a dead one, because it provides protection, mobility, and access to new mating opportunities. This makes Strepsiptera fundamentally different from parasitoids. There is no inevitable countdown to host death built into their life cycle. Instead, this is a long-term biological occupation that can last for the entire adult life of the host insect. The Strepsipteran benefits from stability and longevity, while the host pays the price through lost reproduction rather than immediate mortality. From an evolutionary perspective, this is a remarkable solution to the challenges of survival. Strepsiptera have turned the interior of another insect into a permanent habitat, complete with climate control, food access, and transportation. They demonstrate just how flexible insect life can be and how the boundary between one organism and another can become blurred when natural selection finds an opportunity to exploit it. Now we're going to move away from insects. Let's talk about mites, specifically the family Tarsinemidae. This is a family of mites commonly known as thread-footed mites because of their long, slender legs that honestly look more like fine wires. These mites are tiny, even by mite standards, but what they lack in size, they make up for in evolutionary creativity. Within this single family, multiple lineages have independently evolved ways of living not just on insects, but inside them, turning insect anatomy into habitat. Rather than treating Tarsinemidae as a single story, it makes more sense to tell this tale tribe by tribe, because each group arrived at an internal life in a slightly different way. Tribe 1. Acarapini. The most clear-cut and best-studied internal Tarsinemid mites belong to the tribe Acarapini. These mites specialize in living inside the tracheal systems of adult insects, meaning they occupy the very tubes that insects use to breathe. Entry happens through the spiracles, the small external openings along an insect's body, and once inside, the mites never need to leave. The most famous member of this tribe is Acarapis woodi, commonly known as the honeybee tracheal mite. This species lives entirely within the trachea of honeybees, especially the large thoracic one, which supplies oxygen to the flight muscles. Inside these tubes, the mites feed on hemolymph that seeps through the tracheal walls. Now this might sound bad, but it's better than chewing on tissue and sucking out the hemolymph like a vampire. This feeding strategy allows the host to survive while still supporting a growing mite population. The life cycle of Acarapis woodi is completely internal. Females lay eggs inside the tracheae, and the larvae, nymphs, and adults all develop within the same respiratory tubes. Multiple generations can occur within a single bee over its lifetime, and the mites spread when bees come into close contact with one another, particularly during feeding, grooming, or clustering behavior inside the hive. Young worker bees are especially vulnerable because their tracheal walls are softer and easier to colonize. The effects on bees are subtle at first, but become serious as infestations grow. Tracheal mites, as you'd expect, interfere with oxygen flow, which reduces flight endurance and places metabolic stress on bees. This is especially true in cold weather when oxygen demand is high and bees are tightly clustered. Heavily infested colonies may show poor overwintering success, increased worker mortality, and reduced foraging efficiency. It's very important to state that these mites do not kill the bees outright. Instead, they slowly undermine the bee's physiology, turning breathing itself into a shared resource. So if you see an otherwise healthy-looking bee struggling to make it off the ground or off a blade of grass, then these mites might be to blame. Fortunately, beekeepers have developed several ways to manage tracheal mite infestations. Historically, menthol crystals were used in hives as menthol vapors are toxic to mites but tolerable to bees when applied correctly. Vegetable oil patties mixed with sugar can also reduce mite transmissions by interfering with mite movement between bees. The most effective long-term solution, however, has been selective breeding, because many modern bee lineages show natural resistance to Acarapis woodi, through grooming behavior or physiological traits that make the tracheae less hospitable. Tribe 2, Tarsinemidae. This second group includes mites that are closely associated with insects but tend to occupy protected internal or semi-internal spaces as opposed to respiratory systems or completely internal cavities. Members of this tribe are often found in beetles, ants, and other insects where they exploit anatomical features like glandular openings, membranous folds, or inverted tissues that blur the line between external and internal space. Their feeding tends to be slow and low impact, which allows the hosts to function normally. There's not as much specific species detail to go into on this tribe because they aren't famous like the tracheal mites, but just know that this second tribe isn't completely internal in a traditional sense. The third tribe, however, scientifically known as Tarsinemidae, is probably the most specialized and intimate of internal associations. These mites show extreme host specificity, which means they're often tied to a particular insect species only. Several members have also been described as being endosomatic, meaning they live within the organism just like the tracheal mites. Species and genera such as Tarsinemidae have been found inhabiting reproductive tissues, glands, or soft internal membranes of beetles and other heavily armored insects. By exploiting internal spaces, these mites gain protection, stable temperature, stable humidity, and reliable access to nutrients. Importantly, they do not require host death to complete their life cycle because they depend on long-term coexistence and are actually transmitted through mating, close contact, or social interactions. What unites these three tribes is that none of them rely on killing their host as part of their life cycle. They reproduce inside the insect, sometimes with multiple generations occupying a single host over time. The effects on the host are typically cumulative rather than immediately lethal, and range from reduced endurance or fertility to subtle physiological stress that only becomes apparent under challenging environmental conditions. From the mite's perspective, the interior of an insect body offers a stable, protected environment with built-in transportation and access to plenty of resources. From the outside, an insect carrying Tarsinemidae mites often appears completely normal, but internally, its body has become shared space. And that is where we're going to end this episode of Insects for Fun. I hope you guys enjoyed this episode, and as always, please make sure to rate the show 5 stars wherever you listen. And if you like, the Patreon has bonus episodes and ad-free episodes as well as vlogs. Or if you just want to give the podcast a shout out to people you know in real life, that would also be incredibly helpful. Thank you again for listening.